right now we're continuing to work with transformations with matrices, chapter 4, section 4. We have a little word problem here. It says Shelby and JC are making a new road. Unfortunately, the road will pass through 5 ancient trees, indicated by the small dots. We got a tree here, 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 and here. Got 5 ancient trees. This is the desired new road. So what they need to do is they need to move the trees to the locations indicated by the large dots. Well, maybe they can't move the road. Maybe the road has to be there. Okay, that's a good idea. Maybe move the road. But they're going to transplant. They're not cutting them down. They're moving them.
They're just unrooting them from their home that they've been in for
very
years.
carefully. I didn't say they were large trees. They were just ancient trees. Now, sometimes trees. I know ancient means. I know if it was a redwood, yes, it would be very large, right? But if it's a bonsai tree, it's not going to be very big. So it says we need to write a matrix that represents this what? Translation. So that gives you a hint. This is a translation matrix. Okay? Now, whenever you're building a translation matrix, we have to move our x's and our y's. So remember, x is on top, y is on the bottom. And you said 1, 2? I'm going to have to disagree with you. Well, because we need to move our x's before we move our y's. Ooh, very good. So right here, notice, we went over 2 units and we went up 1 unit. Not just one time, but we had to do it how many times? 5. So my suggestion is all of your x values for every single tree is moved over 2 units. Which direction? 2 units to the right. Every single one. You did it backwards. You did it backwards? And then all of the y values are going what? Up 1 unit. Every single one of those. This right here would be the answer.
No, it's not.
No, it is. No, it really is. That's the answer. I know. But now we know how to move them. We just move them over 2 units and up 1 unit. It's all good. All right, let's go down to the next part.
The cars pollute the air around the trees.
Now, number 13 is dealing with the concept called mirror symmetry. All right? Kristen, A came over. No, we just gave her aliens away. Whoa, Batman. So much for Batman. All right, found only half of an image with mirror symmetry about the line, keyword, y equals x. All right? So the vertex matrix of the visible part is this. We have to find the coordinates of the hidden vertices. So basically, here's the issue. We've got a line called y equals x. So I'm going to do the up line. That's y equals x. Approximately. That's what y equals x looks like. And we have what? We have points on one side and points on the other side. So we have points over here. And they have to be a mirror image of points over here. Now, what does mirror symmetry look like? Let me show you.
Exactly the same.
Exactly. So if I have a point here, the other one has to be exactly right there. If I have a point here, then I have to go perfectly on the other side. Put it there. Now, with the matrix, we have these points. We have 4. We have a 4 and a 2, a 5 and a -5, and a -2 and a -4. What I want you guys to do is look for the matrix that allows us to reflect things across y equals x. Yes, ma'am.
It's 0, 1, 1, 0.
It's 0, 1, 1, 0. Why is it very important to put this matrix on the left side and not on the right? Because this is a 2 by 2, and this is a 2 by 3. And so this number here, this number of columns has to match this number of rows. Okay? So what's our final answer going to be? A 2 by 3. Now before we get a long process, let's highlight a couple of things. Highlight your rows in one color. Highlight your columns in another color. Alright? Alright, here is everything set up really fast. Okay? What we did here is this right here, where the hand is. All right? This is the first row times the first column. 0 times 4 plus 1 times 2. And the second one is 0 times 5 plus 1 times negative 5. So I set everything up. All right? Notice a pattern here. What's happening with the 0? The 0 is being multiplied to all the numbers where? In the first number in the first column, right? Every single time. The 0 is being multiplied to the 4, the 5, and the negative 2. What's the 1 being multiplied? All the numbers that are in the... So the trick is, everybody, if you start out with a 0, don't do the long process. Just move over to the 1 and realize, hey, the 1's being multiplied to all the numbers that are in the bottom. So Angela, automatically, what's our final result going to be in the first row? It's going to be a what?
2.
A 2. A negative 5. And a negative 4, because basically we're taking the 1 and we're multiplying it to all the numbers in the bottom row. So what's the shortcut for this one? Instead of writing this whole long thing out right here, we're going to take the 1, and what's the 1 being multiplied to? All the ones that are in the top. And a 0 is being multiplied to all the numbers in the bottom, and what does 0 do to any number that's being multiplied? Makes it 0, right? So what's the bottom row going to be? A 4, 5, and by the way, these are the hidden vertices. That is the answer to this problem. These are the hidden vertices. All right, number 14 is dealing with a rotation. All right. Right now, Annette used the digital camera to take a picture. Because she held the camera sideways, the image on her computer screen appeared sideways, unfortunately. In order to transform the picture, she needed to perform a 90 degrees clockwise rotation. What matrix represents this transformation? So we're dealing with a what? A rotation.
X-axis.
Okay? We're doing a rotation of what? 90 degrees clockwise. So I'm going to make them do a little drawing here, a little animation. All right? Ooh, it's really not going to be that nice. All right. So for example, right here. That's an arrow. That's pointing, we'll say, north. Okay? Now, if I take the same arrow and I rotate it 90 degrees clockwise, that's going 90 degrees clockwise from here going, yeah. So basically, if that was north, now I'm going east. And that's a 90 degrees clockwise rotation. Well, if I wanted to go east, but I'm saying, I'm sorry, you cannot go east. You must go any way but clockwise. Then you would have to go counterclockwise. So, right here, we have to keep going. Oh, that's 90 degrees. We've hit 270 degrees, and now we're at, sorry, 180, now we're at 270. Yeah. So right here, from here all the way around going counterclockwise, that's 270 degrees. So now you look at your table, everybody. You go to your table that you should have in your journal. All right? And you say, rotation matrices, we needed to go 270 degrees counterclockwise, and that's the matrix that allows you to be able to do that. So the final answer to that problem is simply that matrix. That's what you would have to multiply all those points by to get it to turn 90 degrees clockwise, also known as 270 degrees counterclockwise. All right. I'm not going to do number 15 for you. All right. Just simply doing a what? A vertex matrix for this area. All right, vertex matrix. By the way, this is a vertex right here. You have 4 of them. Okay? So you have 4 x coordinates, you have 4 y coordinates, and it needs to be filled in right here. However, it is pointing what? It's pointing northeast. Now, on problem number 16, it wants us to go from northeast to what? Northwest. So let's think about what we have to do. If this right here is going northeast, We want it going what? North, west. So we want it going this direction. So basically, how have I turned? What have I turned? How many degrees? 90 degrees, which direction? Counterclockwise. Very good. We went 90 degrees counterclockwise. So if we go back to this, you guys see this right here? There's your, it says multiply the what? Multiply the vertex matrix on the left by that right there. 0, -1, 1, 0. So here's what I want you to do. Take the vertex matrix that you found for that arrow, all these points. How many points do you have? You have 4 of them. And what are you going to multiply them by? 0, -1, 1, 0. 0, -1, 1, 0. So I'm just going to pretend. Right here I have A, B, C, D, E, F, G, and H. Those are my coordinates, okay? Now, what is the -1 going to be multiplied to? All the numbers in the bottom. And what is the +1 going to be multiplied to? All the numbers that are in the top. So if you do this correctly, now by the way, the order of your ordered pairs does not matter, just the correct ordered pairs. All right? So right here, everybody, let's say, for example, one of your ordered pairs that you were needing to find was a -1, 1. And another one happened to be a 1, 1, and then 1, -1, and then maybe a 6, 6. So let's say those were your ordered pairs, okay? You're going to take the -1 and multiply it to which? All the numbers that are in the bottom. And then you're going to take this one and multiply it to all the numbers that are in the top. All right? And your final answer, everybody, will be this. Over. That's just a clue.